So we're starting today taking a look at these rules because they're actually going to lead us into our new work for today. So first up, we're doing x to the power of a times x to the power of b. So if I multiply variables, what do I do with their exponents? We add them. And so this would become x to the power of whatever a plus b is. What about the next one? X to the a divided by x to the b. When I divide x's, what do I do with their exponents? We subtract them. And so that would become x to the power of a minus b. And the last one, we have a power to a power. When you have a power to a power, what do we do with those two powers? We multiply. And so x to the power of a all to the power of b is x to the power of a times b. Now this, of course, should be old, familiar stuff. If it's something that's rusty for you, of course, make sure you have it written down because you are going to need to know it going forward. But the interesting thing is that, of course, we've been dealing with logarithms recently. Logarithms undo exponents, right? So actually logarithms fall under the umbrella of exponents here. And so just like there are these kind of rules that we can do with our exponential type stuff, we can do it with logarithmic as well. In fact, you're going to notice even the same patterns are going to hold. It's like this first one. The multiplication led to addition. And then division led to subtraction. And a power to a power, that is an exponent, led us to multiplication. I actually remember it as, the order of operations, the old PEMDAS. You'll notice multiplication leads to addition. Division leads to subtraction. Exponents lead to multiplication. Notice we're basically just going down one rung of the ladder of the order of operations. This is a nice way to remember that. But these same rules that you know there can apply to logarithms as well. So this is our new learning for today. Please add this to your notes, and then we're going to see how we can actually use and apply it. All right, so we're going to now use those rules to expand these logarithms and then see that there's actually a little bit of simplifying we can do by using this information. Because like right now, as I first look at this, there's not much I can do with it without any special rules. But you're going to find there is something we can do now that we know those. So this first one, log base 5 of 25x. Which rule are we going to use? Of those three rules that you just wrote down, do you think this would be the first, the second, or the third rule? Well, as I look inside here, I see 25x. That means 25 times x. So we go to the one that has multiplication inside of the logarithm. That's our first rule. And so I'm going to be applying this rule to this. So notice, it's going to be log base b becomes log base b, log base b. So the base is going to be the same every single time. In fact, it has to be the same for this to work in either direction. So I'm going to start by writing log base 5. And then the two things that are multiplied is what I care about. So the first thing that's multiplied inside here is the 25. So it's going to be log base 5 of 25. A little side note here. You notice I just wrote log base 5, 25, no parentheses. Why did I leave off the parentheses? Because I'm lazy. Writing the parentheses like that is not only good, but in some ways it can be a little clearer depending on how comfortable you are with these. So include the parentheses, don't include the parentheses, it means the same thing in this case. That being said, the parentheses up here were actually required because we were trying to tell it that the whole 25x was inside the logarithm. All right, then plus log base 5, and I'm doing the plus because of this plus right here. Log base 5 of the second number that's multiplied inside. In this case, that's the x. So it's going to be log base 5 of x. When we do that, this is what it becomes. Now, why would we want to do that? We can simplify this further. I hope you've gotten used to logarithms enough by now that you actually know what this value is. Because remember, when we look at a logarithm, we can see it as the base to the power of what equals our number. 5 to the power of what equals 25? Well, 5 squared is 25, so yes, it's 2. So I can just turn that part into a 2. And so you notice this thing simplifies down into something that looks much more reasonable. And that's what we're going for when doing these. All right, write down the next problem. Then we're going to walk through that one using the same kind of ideas. And for this second one, which rule are we going to be using? Again, looking at your notes, you just took down the first, the second, or the third rule. Well, to answer that, we look inside the parentheses and we can see we're doing division. Yep, that is the second rule. And so I know I'm going to this rule now. The division is going to lead us into subtraction. So the first thing I write is I'm going to be writing out 2 logarithms. Both of my logarithms are going to be log base 3. I am subtracting them. I know that much already. Now, whatever number's on top has to go first. Order does matter with these because, of course, division and subtraction in both of those operations, order matters. So the first number is going to be whatever's on top. In this case, that's the 9. And then the second logarithm contains whatever was in the denominator. That's the n value. And so in this case, that's going to be x. So we end up with log base 3 of 9 minus log base 3 of x. And again, we look, can I simplify something here? Well, is log base 3 of 9 going to be a nice, pretty whole number? Well, do you know 3 to the power of what is 9? Yes, we do know that. And so we do it. 3 squared is 9, so log base 3 of 9 is 2. Now, what if the answer was no? What if it gave us a decimal? We'd just leave it in log form then. We only need to really simplify it if it gives us a nice, pretty number. If it's something irrational or something like that, don't worry about it. All right, last one. Make sure, of course, you have it written down. Log base 4 of 64 to the power of x. And of course, when you write it, make sure it's clear on your paper that the x is your exponent there. And so again, I want to think about which rule am I going to be using. Well, you can probably guess pretty quick, right? Especially since I gave you 3 rules and then 3 problems. This is going to be the one we haven't used yet, but how do we know? Notice I have an exponent inside of my logarithm. Whenever I have the exponent inside of the logarithm, it tells me I'm using that third rule. All right, so now, knowing that, I'm now going to go ahead and use that. Notice that the exponent on the inside actually becomes the first thing I write, because I'm multiplying the logarithm by whatever the exponent is. So that's going to be the x. So I pull the x out, and then notice what's left here, the log base b of m. That's everything exactly as it was except for the exponent. So it's going to be the same log base 4 of 64. And again, you can put parentheses around the 64 or leave them out. It means the same thing because it's just one thing inside of the logarithm. And so now that I have x times log base 4 of 64, I look to see if I can simplify it any further. Do we know what log base 4 of 64 is? Well, that one sometimes we know, sometimes we don't. So let's check it here. What's 4 times 4? 16. What's 16 times 4? 64. So that does work. Notice it took 3 of them, and so log base 4 of 64 then just equals 3. So that's just going to be x times 3, although I don't really want to leave it like that. Let's clean that up. Write it as 3x as our final answer. We can use these same rules to go the other direction as well. And so we're going to be using some of these rules to now go ahead and combine logarithms into a single logarithm. So again, write down the first one, then we're going to go through it together. Now, one important thing to note here is that the addition here is taking place between the logarithms. It's not log of x plus y inside of the logarithm. The addition is outside. So that's how we can actually use those rules. So, which rule am I going to need here? The first, the second, or the third rule? It's got to be the first, yeah. That's the one that actually has the addition in it. And so, I know I'm going to be using this rule. Just in this case, I'm going from the right side to the left side. All right, so knowing that, notice first of all, I'm allowed to do this because they're both log base 3. If those bases were different, I wouldn't be able to do it here. So the first thing I write is log base 3 of, in this case, I do need parentheses because I'm going to have multiple things inside of my logarithm. All right, and so notice the stuff that's inside the logarithm comes from the two values that were in our log. So in this case, that's the x and that's the y. Addition changes into multiplication, so it just becomes log base 3 of xy. And in this kind of a case, that's all we can do. There's nothing else that we're going to be able to do to simplify that any further, but it already did simplify quite a bit, so that's actually making our life easier. Let's head over to the next one now. 3 log 2 plus 3 log 5. First of all, am I going to be able to combine those logarithms? Well, in order to actually do a rule like what I used over here, remember we have to have the same base. Do these two logarithms have the same base? Well, I don't even see a base written in there. If we don't write the base in, what is it? 10. So both of these then are actually log base 10. Well, since they are both log base 10 then, we can combine them, but we're going to have to do something else first before we can just straight up combine them. Because you'll notice I got these numbers out front. I need to get rid of those numbers out front first. What do I do with a number that's multiplied out front of a logarithm? Well, this is one of our rules. So take a look through your rules. Where do you see something multiplied out front of the logarithm? Yep, that's the third rule. And so this problem is actually going to use two rules. It's going to start with the exponent rule, and then we're going to go to the multiplication addition rule. All right, so first up, for the exponent part, this is going to become log of, well, the 3 goes in as the exponent, and so it's going to become 2 to the power of 3. Now I only do one thing at a time, so I'm going to leave the plus there right now. I don't want to combine it all at once, just do one thing at a time. And so then I go to the other one, which is going to be log of, think about it yourself first, what's it going to look like? Should get 5 cubed there. Now that we've done this, we're now going to go ahead and simplify a little bit. Well, as I'm looking at this, really before I go too much further, I can actually know what 2 cubed and 5 cubed are. So I'm going to go ahead and do those next. 2 cubed, of course, is 8, and 5 cubed is 125, so I'm just going to turn them into those. All right, and now that I have that, I've simplified each of those logarithms as much as I could up to this point. Now I'm going to go ahead and take care of the addition part. Now when I add logarithms, what am I going to do with the stuff inside? We're going to multiply them. And so I'm now going to, on my next line, write it as a single logarithm, but in order to do so, I have to multiply the 8 by the 125. That happens to give us 1,000. All right, so this is already looking a lot simpler. The only question is, can we simplify it any further? Is this one of those values that we can know? Well, it's saying 10 to the power of what is 1,000. Well, the nice thing about anytime you multiply factors of 10 is all you're doing is adding zeros. So 1,000 is 3 tens all multiplied out together. And so the answer just boils down to be 3. And that's part of the power and the usefulness of these rules, is it allows us to take values that would otherwise give us really nasty looking decimals and manipulate it to a point where we can do it much more easily. Notice we didn't even need a calculator for any of this. And so we now move on to a couple more problems to practice this idea. Notice we're writing them first as a single logarithm, so I'm going to want to be combining, and we'll simplify anything we can, if we can. All right, so this first one, I have subtraction going on between the logarithms. All right. Can I actually combine those then? Well, they're both base 4, so yes. We're going to be using the division subtraction rule here. And again, we're just going from the subtraction side over to the division side. So I'm going to be writing first log base, same thing. Has to be the same base, right? So it's going to be log base 4 of, and I am going to put parentheses here because I'm putting multiple things inside. Remember, order does matter with division and subtraction. So the first number always has to go on top. So that's going to be 32 over the second number, which always goes on bottom, which is 2. So we're going to have log base 4 of 32 over 2. Now, the nice part about that is, of course, we can simplify that at least somewhat, right? Because what's 32 over 2 equal? Yeah, 16. So that just equals log base 4 of 16. So already, that's at least a lot cleaner. The only question is, can we go even one step further past that? Is this going to be a nice, pretty number? Yes, because 4 squared equals 16. Therefore, 4 to the power of 2 is 16. The whole thing equals 2. All right. Then on to the second one. Log of 32 divided by log of 2. Looks somewhat similar, but also looks different here, right? So as we look at this one, we again ask ourselves, which rule are we going to be using here? Well, I see division. So I'm probably thinking along these lines, because this is the only rule that we just wrote down that has division in it. But it doesn't look the same, does it? This one, you notice we have a log on top and a log on bottom of the division. We're actually dividing two separate logarithms, whereas this means we have one logarithm and the division is happening inside of the logarithm. We can't use that rule then. But you actually do have a rule that will allow you to simplify this. It's actually one that you've been using for like a week now. I just haven't given it to you in this order before. We've used stuff that looks like this before, right? In fact, you've calculated it often. You put this into your calculator. This is our change of base formula. Because remember, if I want to calculate log base b of y, I can just do log of y divided by log of b. This is the log of y over log of b kind of phase here. So we can go ahead and use that to go backwards as well. And so we can see that this is the same thing as log. The base is whatever number was on the bottom, of course. Base is always on the bottom. So it's log base 2 of whatever number was on top. So it's of 32. So really, that just equals log base 2 of 32. So we simplified it into a single logarithm. Good, that's what we wanted to do. Last question, though, can we simplify that? Well, is log base 2 of 32 a nice, pretty whole number? Yes. It's actually one of those values I had you go back and memorize like a month ago. Hopefully you got some of those down, because they do come up often enough. 2 to the power of 5 would equal 32. So log base 2 of 32 just equals 5. I threw this one in here just because I don't want you to forget about it or get it confused with what we're doing here. So just keep in mind which one to use when as you go forward.